The interquartile range is reported as a measure of dispersion when a distribution is skewed or there is an outlier. To calculate the interquartile range, it's a 75th percentile minus a 25th percentile. So it's very straightforward subtraction, and you're done. That is, it's taking the high value for the middle 50% of the data and subtracting from it the low value of the middle 50%. The challenge, when you're trying to do this by hand, is to figure out what is your 75th percentile and what is your 25th percentile. So let's take a look of when the sample is size 10. And we'll go ahead and use what's known as Tukey's median of halves. So for a data set of size 10, we're going to divide it into fourths. Q1 is a 25th percentile, Q2 is our median, and Q3 is a 75th percentile. And you're saying, wait, you have 10 scores. How do you evenly divide that into fourths? And you're right, it's tricky. So here's how we apply Tukey's median of halves to address that. So to get the 50th percentile, the median, the middle of the entire data set when we sort it from low to high, what we do is we just find where is the middle. With 10 scores, we're going to have 2 scores are in the middle, the 2.5 and the 2.7. That's fine. We take those 2 scores, we add them up, and we divide by 2. We get their average, and that's 2.6. That's our median. It's also called Q2. Now, what about the 25th percentile? The 25th percentile is the median for the bottom half of the data. So we take our lower 5 scores, and we bring them on down, still sorted, and we take the middle value of it. And so the middle value is 1.9. So our Q1, our 25th percentile, is 1.9. Q3, the 75th percentile, that's the middle value of the upper 5 scores. And so, again, working with a sorted data set, those upper 5, we see that 3.5 is the middle value. So Q3, our 75th percentile, is 3.5. The interquartile range is a 75th percentile minus a 25th percentile. So in this case, it's 3.5 minus 1.9. That works out to be 1.6. So for someone who's writing up about this particular distribution, the sample, they would say the sample, median, 2.6, comma, IQR equals 1.6, that's what we calculated here, comma, n equals 10, skewness equals 0.14, was drawn from a strongly positive skewed distribution, median 2.58, IQR equals 2.84, skewness equals 1.63. And again, the only thing that we calculated here by hand was IQR. I guess we also calculated the median because we saw that was the middle value of the entire data set. Okay, so let's switch this down, have a smaller sample size. If you have a sample size of 9, well, it's really easy to find the middle value then for a data set of 9 items, right? So that gives us 2.5. To find the 25th percentile, we take then the bottom 4 values, and Q1, the 25th percentile, will be calculated by taking these 2 middle values, 1.7, 1.9, add them together and dividing by 2 to get their average. So that's 1.8. And the 75th percentile is by taking the upper 4 of those values, putting them in sorted order, taking the middle 2 values, 3.3 and 3.5, adding them together, dividing by 2 to get their average, which is 3.4. So the IQR for the data set with the 9 items works out to be the 75th percentile, which is 3.4, minus the 25th percentile, which is 1.8. That works out to be an IQR of 1.6. And of course, for free in this process, we also got the median. That was the middle value of the entire data set. All right, there you go.